Hi, and welcome to Algebra 1 BCPS-TV style. My name is Laura Potter, and I'm your host for today's lesson. Before we start doing math, let me tell you a little bit about me. The 5 humans, 2 dogs, and cat in the pictures are my family. We enjoy playing board games at dinner time. You'll meet everyone in a minute. Our dogs, Maya and Honey, love to play fetch and they eat lots of treats. Our cat Sassy can almost always be found sitting in the sun or laying in a box. To start, we're going to warm up our brains with a Think About It task. Today's Think About It asks you to look at expressions A and B and notice something that is alike and different about the expressions. Expression A is x to the third power plus x squared plus x plus 1. Expression B is 2x squared minus x squared plus 4x minus 2x plus 9. Take a few seconds to think about what you notice that is alike and different about the two expressions. Let's hear from my family to learn about their ideas. As you listen, look at the expressions to help you make sense of what they noticed and see if any of the things that you noticed are the same or different than what they noticed. Hi Lily, what did you notice?
I noticed that both expressions have x and x squared. Something different that I noticed is one expression has all addition while the other has addition and subtraction.
So what's that vocabulary word that describes the small 2 next to the x and the x squared?
Exponent.
Thanks, Lily.
You're welcome.
Hi, Spencer. What did you notice?
I noticed that both expressions have constant terms and expression B has like terms.
So what are the constant terms?
In expression A, it's 1, and in expression B, it's 9.
And you mentioned that expression B has like terms. What are the like terms?
There are 2 pairs of like terms, one being 2x squared and negative x squared, while the other pair is 4x and negative 2x.
Oh, okay. And does expression A have any like terms?
No.
All right. Thanks, Spence.
You're welcome.
Hi, Victoria. What did you notice?
I noticed that they both have 2 terms with exponents. I also noticed that expression A has 4 terms and expression B has 5 terms.
Well, how did you know that expression A had 4 terms and expression B had 5 terms?
I felt it though.
Oh, all right. And Spencer just said that there were like terms in expression B. If you combine those like terms, would that change your answer?
Yes, expression B would change from having 5 terms to 3 terms. 2x squared minus x squared equals 1x squared, and 4x minus 2x equals 2x.
Ah, I see. Thank you, Victoria.
You're welcome.
Finley, what did you notice?
I noticed that both of the expressions are polynomials. I also noticed that one expression has only coefficients of 1 and the other has coefficients other than 1.
So let's talk about the coefficients for a second. What are the coefficients in expression A?
1, 1, 1, and 1.
What are the coefficients in expression B?
2, negative 1, 4, negative 2, and 9.
That was funny that expression A only had coefficients of 1. Thanks, Ben.
You're welcome.
Hi, Tim. What did you notice?
I noticed that they are similar because they both have a single variable, and I noticed that they are different because one is cubic and one is quadratic.
So which expression is cubic and which expression is quadratic?
Expression A is cubic and expression B is quadratic.
How do you know?
I know that because expression A has the highest exponent of 3 and expression B has the highest exponent of 2.
Thanks, Tim.
You're welcome, Laura.
The material covered in this first mini lesson is the same as the material in the print packet for Algebra 1 during the week of April 13th. On the screen is our first learning objective for today. Today, we will change subtraction to adding the opposite in order to subtract polynomial expressions. In the Think About It task, we looked at 2 polynomial expressions. Now, let's extend this thinking to use adding the opposite to subtract the expressions. Before we get to subtracting polynomial expressions, we will learn about a tool that will help us understand the polynomial expressions that we will be subtracting. On the screen are algebra tiles. Algebra tiles are a mathematical tool that help us to visualize the polynomial expressions. There are 3 different types of tiles that we will use. Each tile has two different colors. For example, x squared is the large square. A positive x squared is represented by the blue square, and a negative x squared is represented by the red square. Positive and negative x are represented by rectangles. The green rectangle represents positive x, and the red rectangle represents negative x. The small squares show units or constants. The small yellow square represents a positive unit, and a small red square represents a negative unit. Finally, let's look at what are called zero pairs. Zero pairs are two tiles that have a sum of 0. For example, the green and red rectangle represent 0 because one of the tiles shows positive x and one of the tiles shows negative x. When we are subtracting polynomials, we will use the tiles to help us visualize what is happening mathematically. Now we're going to learn about it. Here's our first example of subtracting polynomial expressions. I will show you two ways to do this problem, one with algebra tiles and one without. The subtraction problem that we're going to start with is x squared plus x minus 1 minus the quantity negative 2x squared plus x plus 1. The first step in this process is to rewrite the subtraction problem as adding the opposite. I changed the subtraction symbol to an addition symbol, and all of the terms in the subtrahend were changed to their opposite. So, negative 2x squared was changed to its opposite, which is positive 2x squared. Positive x was changed to its opposite, negative x. And positive 1 was changed to its opposite, negative 1. The next step is to represent the addition problem using algebra tiles. We'll identify and collect any like terms and remove zero pairs. So you'll notice that the addition problem is shown with the algebra tiles. I have an x squared tile, an x tile, and a negative 1 tile. And I have two x squared tiles, a negative x tile, and a negative 1. The zero pair that I will remove are the positive x tile and the negative x tile. And that leaves me with my answer, 3x squared minus 2. If I want to try this problem without using algebra tiles, I use the same first step. I rewrite the subtraction problem as adding the opposite. I also need to identify any like terms, and I've identified those by using a single red underline, a double orange underline, and a triple blue underline. The next step is to combine like terms by using addition. So I'll start with the red underline, the red single underline. I have x squared plus 2x squared, which is 3x squared. Then my double orange underline, I have x plus negative x, which is 0. And if you think back to the algebra tile example, that was our zero pair that we removed. And I also have negative 1 plus negative 1, which is negative 2. And to write my final answer, I will take the sum of each of the like terms that were collected, and I'm left with 3x squared minus 2. So you can see that it doesn't matter which strategy I use, I'm still going to get the same final result. The next example that we're going to try is x squared plus x minus 3 minus the quantity x squared plus 2x plus 1. We'll begin with the algebra tile strategy. My first step is to rewrite the subtraction problem as adding the opposite. Notice that I changed the subtraction symbol to an addition symbol, and I wrote the opposite of each of the terms in the subtrahend. The opposite of x squared is negative x squared, the opposite of 2x is negative 2x, and the opposite of positive 1 is negative 1. The next thing I'll do is I will represent my addition problem with algebra tiles, identify and collect like terms, and remove any zero pairs. In this addition problem, I actually have two zero pairs. I have a zero pair that's represented by positive x squared and negative x squared, and I have a zero pair that's represented as positive x and negative x. You can see what's remaining is 4 negative units and 1 negative x. So my final answer is negative x minus 4. I can also do the same problem without algebra tiles. I'll begin in the same way as when I solved the problem using algebra tiles, by rewriting the subtraction problem as adding the opposite. This time, I'll identify the like terms by using single, double, and triple underlines for my like terms. Then, I'll combine like terms. I'll begin with the red single underline. X squared plus negative x squared is equal to 0, and that was one of our zero pairs when we solved this problem using algebra tiles. Then I'll move on to my orange double underlines. X plus negative 2x is negative x. And finally, negative 3 plus negative 1, which is negative 4. You can see that my final answer is still negative x minus 4. It doesn't matter which strategy I use, and you get to pick which one you're most comfortable with. Today, we learned how to subtract polynomial expressions by changing subtraction to adding the opposite. And now it's your turn to try some problems. Remember, you can choose to use either method that we learned today. You can either draw algebra tiles on your paper or use the like term strategy without the algebra tiles. But don't forget, there's an answer key at the end of your print packet. The material covered in the second mini lesson is the same as the material in the print packet for Algebra 1 during the week of April 13th. On the screen is our second learning objective. Today, we will use a frame model and the distributive property in order to multiply polynomial expressions. Similar to the previous lesson, I will show you two different strategies to multiply polynomials. Let's get started. So in this first example, I'm going to multiply polynomial expressions. In this case, I have the quantity x plus 1 times the quantity 2x minus 5. This is a binomial times a binomial because I have a polynomial expression with two terms times a polynomial expression with two terms. If you take a look at the first strategy that we're going to use, which is the frame strategy, you'll notice that I have a box with 2 rows and 2 columns. Those correspond with the terms in each of my factors. So I have 2 columns which represent each of the terms in the factor x plus 1, and I have 2 rows which represent each of the terms in the factor 2x minus 5. And now I'll simply multiply the rows and the columns together to get partial products, and then I'll add those together to get my final product at the end. X times 2x is 2x squared. 1 times 2x is 2x. X times negative 5 is negative 5x. And 1 times negative 5 is negative 5. Those are my partial products. To get my final product, I'll add all of my partial products together. So I have 2x squared plus 2x minus 5x minus 5. And I'll scout around and see if there are any like terms. And there are 2x and negative 5x, so I'll combine those together. And so my final product is 2x squared minus 3x minus 5. The other way I can do this multiplication problem is by applying the distributive property. So I'm going to multiply x times 2x minus 5, and then I'm going to multiply 1 times 2x minus 5. Let me show you how that plays out. I'm going to start with x, and I'm going to multiply that by 2x minus 5. Then I'm going to add 1, which is the second term in my first binomial, and I'm going to multiply that by 2x minus 5. Now I'll apply the distributive property again for each of the terms in my expression. So that means I'm going to multiply x times 2x and x times negative 5, and 1 times 2x and 1 times negative 5. X times 2x is 2x squared. X times negative 5 is negative 5x. 1 times 2x is 2x. And 1 times negative 5 is negative 5. I'll take a look around and see if I see any like terms. Yes, I do. I'll combine them together to get my final product, which is 2x squared minus 3x minus 5. And you can see that when I look at my two products, it doesn't matter which strategy I use, I'm going to get the same product. In example number 2, we will be multiplying the quantity 3x minus 2 times the quantity x squared plus x minus 1. This is a binomial times a trinomial. My first factor has 2 terms, and my second factor has 3 terms. And that information is helpful because it determines how I'm going to set up my frame to keep my terms organized. You'll notice that my frame has 2 columns, which correspond to the 2 terms in the first factor, 3x and -2. And there are 3 rows, which correspond with the 3 terms in the second factor, x squared, positive x, and -1. Now I'll simply multiply the corresponding rows and columns together. 3x times x squared is 3x to the third. -2 times x squared is -2x squared. 3x times x is 3x squared. -2 times x is -2x. 3x times -1 is -3x. And -2 times -1 is +2. So I'm going to take all of my partial products and add them together. I have 3x to the third minus 2x squared plus 3x squared minus 2x minus 3x plus 2. I'm going to take a look around at my expression and determine if there are any like terms, and there are. I see a -2x squared and a +3x squared, but I also see a -2x and a -3x. So I'm going to have 2 sets of like terms that I'm going to combine. My final product is 3x squared plus, it's not 3x squared, it's 3x to the third, plus 1x squared, but I'll just write x squared, minus 5x plus 2. In the second strategy, I'm going to apply the distributive property. I'm going to take the 3x and the -2 from the first factor, and I'm going to multiply them by everything in the second factor. Going to multiply 3x times x squared plus x minus 1, and I'm also going to multiply -2 times x squared plus x minus 1. I'll have to apply the distributive property again. 3x times x squared, 3x times x, and 3x times -1, and -2 times x squared, -2 times x, and -2 times -1. 3x times x squared is 3x squared. 3x to the third. I keep doing that, I keep making that mistake. I'll have to remember not to make that again. 3x times x is positive 3x squared. 3x times -1 is -3x. -2 times x squared is -2x squared. And -2 times x is -2x. And -2 times -1 is +2. I'll look around to see if I have any like terms. I have a positive 3x squared and a -2x squared. And I have a -3x and a -2x. So I'll combine those like terms together to get my final product, which is 3x to the third, didn't forget that time, plus x squared, that's the sum of these 2 like terms, the 3x squared and the -2x squared, minus 5x, that was the sum of -3x and -2x, plus 2. And when I take a look at my final answers, I can see that the products are the same. So again, it doesn't matter if I'm choosing to use the frame model or I'm choosing to use the distributive property. Personally, I like the frame model because it helps me keep all of my information organized in a logical way, and I can see all of the parts of the distributive property happening. But you get to choose when you move on to the try it section and try some of these problems. Today, we learned how to multiply polynomial expressions by using a frame model and the distributive property. And now it's your turn to try some problems. Remember, you can choose to use either method you learned about today. During the try it activity, you're going to be looking for repeated reasoning to make some generalizations about multiplication of binomials that have a special structure. Don't forget, there's an answer key at the end of your print packet. Thank you for joining me today. I hope that you feel confident getting started on the problems in your print packet. Practicing what you learned is so important. Take care and stay well. See you soon. These directions are provided to show you how to access the print materials. First, go to www.bcps.org. Once you've accessed Baltimore County Public Schools website, select the Coronavirus COVID-19 Updates link at the top of the page. Scroll and select Student Learning Resources. Scroll and select Middle and High School Secondary Resources. This will take you to a set of file folders that contain the print resources for secondary subject areas. Select Secondary Mathematics, April 6th to 24th, and this will provide you with all of the print materials for the secondary mathematics courses. Thank you.